All right, we are recording. Hello, everyone. Welcome to the next edition of the Autodesk Forge Online Bootcamp. My name is Petr Broz, and I'm joined here by my colleague Varun. And we are Forge developer advocates that will be your guides through this session today. Okay, what is this event about? Some of you may already know, but for those of you who are joining us here for the first time, the online bootcamps are basically a way for you to get a more guided approach to some of the standard Forge tutorials that we provide, we as developer advocates. Some of you may already be familiar with this website, learnforge.autodesk.io. That's where we keep some of our basic Forge tutorials. And for those of you who maybe don't feel as comfortable going through these tutorials by yourself, that's where we offer these online bootcamps, where the way this event works is each day of the bootcamp, we choose one specific tutorial from this LearnForge website, and we basically live code through that specific tutorial, showing you how to do that. So again, we're not going to be coming up with some new special applications here. This event is all about showing you, giving you more about, hand-guided tour and demonstration of the tutorials available on the LearnForge website. So again, each day of this 4-day event will focus on one specific tutorial, and during each webinar is going to be split into 4 sessions, where at the beginning of the session, we will go through a part of the tutorial, and then we'll give you some time to follow our steps, basically, and maybe submit any questions if you run into any problems. And then we meet again for the second session of the same tutorial. We go through another part of the tutorial. We answer questions if you have any in the meantime. That's how the event works. So again, it's a more guided approach to the standard tutorials that we provide, if that's an approach to learning Forge that you're more comfortable with. All right, day 1, we're going to be looking at the basic Forge application that pretty much all our customers start with, and that's sort of like dipping your feet into some of the standard components of the Forge platform with authentication, figuring out how OAuth tokens work, how standard simple data management works, how you can upload a file and translate it for previewing in your custom application, sort of like building your own viewer app. That's what we're going to be focusing on today. All right, we're day 1, and this is the application that we're going to be building. Again, this is the one of the standard apps from the tutorials on the LearnForge website, and the app is going to look like this. It's going to have a simple user interface. We're just going to have a simple sidebar allowing us to manage a preview, see a list of files that we already have in our new Forge app. It'll allow us to upload new files and translate them for previewing in a client-side component that's also part of the Forge platform that we call Forge Viewer. So this is going to be your very own viewer app, where you can upload 3D designs or 2D drawings and preview them, and you can share links to these designs with your colleagues so that they can preview these designs as well. All right. Now, for the 4 sessions we have prepared today, in the first one, we're going to take a look at the basic setup. We're going to show you how you can set up your editor and from a runtime environment. In this case, specifically, this presentation is focused on Node.js. We also run another webinar in parallel with this one that's ran by my colleague Adam Nagy, and that webinar is basically the same tutorial but focused on .NET. We're gonna show you how to make sure that you have Node.js ready and an editor and some Forge application records or credentials that we're going to be using later on. And then in the next session, in session 2, we're going to start implementing a basic Node.js Express.js application. We're going to provide some standard authentication endpoint for generating access tokens. In session 3, we're going to add logic for uploading and translating our models. And finally, in the last session today, we're going to put together all this server-side functionality with a piece of UI where we're finally going to allow our users to upload files, translate them, and open them in the viewer. Okay, so let's start with session number 1. For this part, we're just going to focus on 2 things. We're going to want to make sure that you have a Forge account available and some kind of Forge application, and I'll explain what that means in just a second. And we're also going to help you figure out, again, that make sure that you have your Node.js environment ready to use and some kind of an editor available for the upcoming sessions. Okay, first of all, what you want to make sure is that you have a Forge account. Right, for that, let me head over to the Forge portal, the official Forge development portal. That's forge.autodesk.com. And in there, you want to log in or sign up. The Forge account is free. It'll just allow you to, again, start maintaining your Forge applications. So let me sign out from here. All right, this is what it's going to look like. If you don't have a Forge account, you can simply create one. You should be able to just log in here with your, use your Forge account to just get access to all the functionality provided by the platform. So again, make sure you have you can log in into the forge.autodesk.com website. And then the important part is going to be under your profile in the top right corner when you log in. So let me log in again. You will see a section called My Apps. I'm already there, actually. So let me go back to the front page. So again, through your profile in the top right corner, you're going to have access to My Apps. This is where you're going to maintain all the records of all the different Forge applications that you're planning on developing. Now you can see I already have quite a few of these here. I'm going to create a new one. So basically, a Forge app, what it means here, it's a set of credentials that you're going to use to authenticate yourself to the Forge platform, right? Whenever you want the Forge platform to do something for you, you'll need to authenticate yourself in a certain way. And it's recommended to have different Forge applications, for example, for different products that you might build, because that way these will be siloed and data owned by one application, of course, will not be accessible by another Forge application. Oh, and I'm seeing a comment in the chat. Please make your camera screen a bit smaller. Oh, I'm not sure if I can do that. I don't really see how big my camera screen is. I'm sharing. Let me see if I can find it out. Let's see. Video settings, maybe I can. No, I don't seem to be able to set the size of my camera. So I hope that won't be that big of an issue. Okay. So also one more thing, now that we're on the topic, one thing I forgot to mention is all these webinars, all 4 days of this bootcamp event are recorded and will be shared with all of you together with the presentation slides after the event. So don't worry if you miss some piece. Again, the recordings and the presentations will be made available after the event. Okay, back to our application. So again, here you're not actually building any kind of any piece of software just yet. When you create a Forge application, you're basically generating a sort of username and password for your app that the application will use when communicating with Forge, right? So what I'm going to do here, I'm going to give the app some name. I'm going to call it maybe Online Bootcamp September 2021. I'm going to copy and paste the same thing into the description. In some cases, you will need to provide something called a callback URL. This is important for when you start building applications where you require your users to log in with their own credentials, with their own Autodesk credentials. But for today, for the first tutorial, we're not going to need this, so we can put any arbitrary localhost, or I can just say bar for now. We're not going to use this property today. We're going to need it for the day 2 application we're going to be building on Tuesday, and we can always come back to our app, hit the edit button later on, and update these values when needed. And you can also provide the URL where your Forge application will actually be running. And again, we're not going to be deploying it anywhere today. We're just going to be running it locally, so you can put any value that you need there, or you can any value you want. And again, you can always edit these later. And then finally, at the very end of the form, you'll be presented with a set of APIs that you want to use in your app. Here, I typically keep everything checked by default, because later on, maybe even though I'm not planning on using, for example, the reality capture APIs today, I may need them later. So I typically leave everything enabled. All right. And when we create our application, Forge will generate the new app credentials for us. All right. Your new app is successfully created. And these two values, the client ID and client secret, these are the credentials of your app. Now, the client ID is public. You can share this with others if needed. Client secret is sort of like a password, so you should never share this value with anyone. Here, of course, since I'm going to be showing you how to work with that value, I'm going to expose that client secret here. But that's okay. What I'm going to do after the recording is done, I'm going to use this regenerate button to have Forge generate a new client secret password for our application. But again, it's definitely a good practice to keep this client secret secret. All right, so these are going to be our credentials that we're going to use to communicate with Forge in the next session. All right. And as for the development environment, again, this webinar specifically is focused on Node.js. So we're going to want to make sure that we have Node.js available on our system. If you don't have it, you can simply go to nodejs.org, and we recommend, there we go. And we recommend installing the LTS, that's the long-term support version. If you have an older version of Node.js, that's fine too. I think the only thing that's required is it should be at least version 10, because some of the features that we're using in our tutorials require that Node.js version to be at least 10 or newer. All right, and how do you find out once you have Node.js installed? How do you make sure that it's available for us for later on? We're going to be using a command line here. In my case, I'm on Mac OS, so I'm going to be using a standard terminal with bash in it. If you're on Windows, you can be using the cmd command prompt as well. That's an option. We also recommend maybe to make the experience more consistent. If you're on Windows and you're not sure what kind of terminal environment you'd like to use. I would recommend installing the Git source control management system. We're not going to need it necessarily for our tutorials, but it's a pretty helpful tool, especially if you start working with GitHub and you want to clone code and start versioning and maybe pushing your own commits to some GitHub repository. So it's definitely a good tool to have. And if you download Git for Windows, I believe it comes with Bash as well, right? So then after installing Git on your Windows system, you should have access to a terminal very similar to this one. That's going to be the Bash for Git, or Git Bash, I believe. I'm not sure exactly how it's called on Windows, but you'll have access to the same kind of experience, and again, a Bash terminal on your Windows machine. Okay, so how to make sure that we have Node installed and that we have the right version of Node available? Well, you can simply go to your terminal. Excuse me, and you can type Node-V to print out the version of your current Node.js environment. So you can see in my case, I have a version 14 installed, so we're good in this case, right? We'll be able to initialize our first Node.js application in the next session and start building and running that Node.js code actually. All right, and as for the development environment for the actual editor, you're free to use really whichever editor you're most familiar and comfortable with. If you don't have a strong preference, I would definitely recommend using the Visual Studio Code, right? So this is not a full-blown Visual Studio. This is sort of like its smaller, lightweight brother. It's a cross-platform editor. It's really good, I believe, especially for web development, right? It's fast. So I would definitely recommend that you give it a shot. And again, we would recommend simply heading over to code.visualstudio.com and getting the stable build for your platform. When you install the editor, it looks kind of like this. It's pretty simple. Again, you'll be able to, it's sort of like a glorified text editor, but of course it can do a lot more, even though not as much as the proper Visual Studio, but I believe it's the right subset of functionality from the full-blown Visual Studio editing that makes this really, really fast and really nice to work with environment. All right, so this is what the Visual Studio Code looks like. And now there is a minor recommendation I would also make if you decide to install VS Code, or if you're already using it. Here's a little tip. We've built an extension for this editor that allows you to access your content in Forge, the different services and content in Forge, without really writing any code at all. That extension is called Autodesk Forge Tool. So if you head over to this blog icon for extension, and if you search for Autodesk Forge or Autodesk Forge Tools, you'll find this extension somewhere, hopefully towards the top. And I'd also recommend that you try and install it. I already have the extension installed on my machine. In my VS Code, you can see it here. Actually, it'll appear, the Forge icon will appear in your sidebar after you install the extension. And then what will happen is when you run it for the first time, the extension will try and see if there are any Forge credentials configured for it already, right? Because as I mentioned earlier, you're going to need some Forge client ID and client secret to authenticate yourself when communicating with the Autodesk Forge platform. So let's see what happens here. If I try and activate the extension for the first time, it'll find out that I actually haven't provided any Forge credentials yet. So it'll ask me if I want to enter them here. And I would recommend that you use that option. Just hit the Enter Forge Credentials. And here you'll see the editor will ask you for some Forge client ID. So for that, I'm gonna go back to the Forge portal, to my ads, right, where I already created my new Forge application. And I'm gonna simply copy and paste the client ID into the editor. That will ask me for the client secret. So you can simply copy it by double clicking the hidden phrase. I'm going to paste it here. Oh, that's too much. And I'm going to choose a region where I want to store my data. So I can just use US for now. Unless you have any special requirements, we can just go with the US geo. And finally, this input will ask me to provide some name for my new environment, my Forge environment, because in future you could potentially have multiple of these configured, and maybe you'll want to be able to switch between them, right? So to easily recognize which Forge credentials you're referring to specifically, you can give it some name. So here I'm just going to call it, I don't know, my env. All right, and now I have my Forge extension for VS Code initialized. You can see here I'm running, I have the my.env environment enabled. If I had more of them, I could click on this item in the status bar and choose, maybe switch to a different environment. But for now, I just have this one. And for now, I don't really see any data just yet. That's fine. That's expected, right? That's what we're going to do in the upcoming sessions, right, where we're going to start adding logic to our Node.js server so that we can create new, we call them buckets that are kind of like folders, so that we can upload files to them and translate them, right? So we're going to be doing all that logic, implementing it from our Node.js server, but we could as well be doing trying all that, creating buckets, uploading files, translating them right from here, from within the editor without writing any code at all. So it's good for debugging if something goes wrong. You upload a file, but maybe the file cannot be translated. It's always good to check the file in here, see if it's if it's got the right size, or maybe if it's if it can be translated from within the extension. So I think it's a pretty nifty tool to have available when developing your first Forge application. All right, that was our part of the demo, and now it's your turn. So again, for the first session, we would like to ask you to again make sure that you can log into the Forge website, the forge.autodesk.com. Then second, we want to make sure that you have your first Forge application created. So again, it's under the profile in the top right corner. If you go to My Apps and create a new Forge application, right, and make note of the client ID and client secret that the portal generates for you, because you're going to need them later. And again, on the development side, make sure that you have either command prompt or some bash terminal available, right? So again, if you're on Windows, I believe you could use the standard CMD or the command prompt as well, but I recommend using the git bash, the bash terminal environment that comes with the git tool. That's also pretty useful to have. So try one of these. Make sure that, again, you can open a terminal environment where you have access to the Node command line tool. And that if you type in Node-v, that you get, that you actually get some response there, right? So that the Node tool is available, and that the version is, again, at least version 10, but we recommend using the long-term support version, which is v14. All right. Okay. And with that, that's the wrap up for our session number 1. So now you're going to have roughly 1 hour and a half before we meet again at 10 a.m. GMT, where we're going to start building our Node.js server, and we're going to start adding some authentication logic to it. And in the meantime, feel free to submit your questions to, you should see a Q&A button in the Zoom toolbar, or maybe post messages to chat, and I'll monitor these, and I'll try and answer your questions if there are any, to make sure that you're unblocked and that you're ready to join us again at 10 a.m. GMT to move on with the session number 2. All right. Thank you, everyone. So let me pause the recording, and I'll leave the screen on. And again, I'll see you all back here in, almost exactly 1 hour and a half. Right. Thank you, guys. All right, we are recording. Thank you, everyone. I think we're ready to move on to session number 2, which is going to be, as I mentioned earlier, we're going to start preparing our first Node.js server application, and we're going to introduce some authentication logic that I'm also going to explain the reason for authentication, how it works, and why it's needed. Before we do that, let's give one more minute to see if there are any questions. There have been a couple during the first session. Varun has been answering those, so thank you, Varun, for that. I haven't seen any questions specifically related to this tutorial, to the first session, so it looks like I'm hoping that everybody's all set and we can move on to our server app. Now, before we get to the coding, here's a simple diagram indicating how this whole collaboration between Forge and your application and your user's browser, how the whole thing works together, right? So basically what we're going to be implementing is this server-side component now. It's going to be our simple server application that's going to be communicating with the Forge servers, with the Forge services. And then our server will also expose some of that functionality through its own endpoints, server endpoints or URLs or whatever you want to call them, so that as we develop later on in session 4, as we start developing our client-side application, we will want to make sure that, for example, in order to retrieve an access token for our viewer, we will be able to call an endpoint, let's say in this case called API Forge OAuth token, on our server, which in turn will receive the token from the Forge servers and provide it back to us, right? So our client side, our HTML and JavaScript in the browser, it's not going to be communicating directly with Forge, at least not in most of the cases. It's going to be communicating with Forge through our own server application, through the endpoints that we decide to expose. There is an arrow here as well that's for one specific case that we're going to explain later when we get to the viewer as well. All right, so what we're going to do is we're going to use the npm tool. That's a node package manager. That's a command line tool that should be also available automatically when you have Node.js installed on your system. We're going to use npm to initialize our new project and install some of the basic dependencies. In this case, it's simply going to be the Express.js server. It's going to be an endpoint. It's going to be a tool that we're also going to need to handle file uploads to our server. And it's going to be the Forge SDKs, right? Because the Forge APIs are web services, basically. So you can communicate with them with any software that can make HTTP requests, right? So there are different third-party GUI clients like Postman or Insomnia, or you can keep making requests to the Forge APIs from the command line if you want to, or from your custom application, right? So any programming language that provides libraries to make HTTP requests can be used to communicate with Forge, right? But of course, we don't want you to go this low level and build every single HTTP request yourself. That's why we're providing SDKs, Forge SDKs for some of the most popular programming languages like .NET, Java, Node.js, PHP, etc. So these basically give you a higher level of abstraction so that to upload an object, for example, to upload a file to Forge, you don't have to build the entire HTTP request with all the required headers with the properly formatted payload, for example. You simply call a method on an object, and under the hood, the Forge SDK will build that request for you. All right, and then what we're going to do to make our life a little bit easier, for those of you using Visual Studio Code, we will create something called log configuration, which is basically a simple configuration that'll allow us to run our Node.js server application in a debug mode from within Visual Studio so that we can put breakpoints in the code, stop them, investigate watch the variables during the code execution, etc. And finally, we'll also prepare the start of our Express.js server. So we're going to build our start.js file, and that's where we're going to define the server itself. For now, it's going to be pretty basic. And we're going to prepare a config.js file as well, which is where we're going to collect all the inputs that we're going to need from the environment, right? So in order to run our application, we're going to need things like the Forge client ID and client secret, for example, that Forge has hopefully generated for you when you create your own Forge app. And we're going to create something called a router for the authentication. And I'm going to explain what a router is when we get to that point. And by the way, all right, so this is demo time. By the way, if you are not sure about some part of the steps that we're taking in here, again, just keep in mind that we're basically following this View Your Models tutorial today. That's the basic viewer application sample. And we're starting with this step called create the server, right? So in our case, we're going to be creating a Node.js application. And we're going to be basically throughout the day today in the different sessions, we're going to be following these steps to build our application at the end of the day. All right, so let's start by initializing our application. In your command prompt, or again, bash terminal, whichever works for you, simply create a folder for your new project. I'm going to call mine maybe day one. And when you go into that folder, again, if you have Node installed, in my case, if I type node-v, let me make this a bit bigger. If I type node-v, I see that I have Node.js version 14.17 installed. You should also have npm. That again comes hand in hand with Node. In this case, I see I have my Node package manager version 6.14 installed. Now, what we're going to do is we're going to type npm init. This is a subcommand of npm that basically initializes a new Node.js project. It'll ask you for a couple of things, like what's the name of the Node.js package. You can keep everything to its defaults, version description, entry point, keywords if you want, author, license. Basically, all this will do is it'll simply create a package.json file in your new project folder. Package.json is basically a file that stores that defines all the information about your project. Who's the author, what scripts can be run in that project, or more importantly, what dependencies that project uses. Right? Now, if we go back and take a look at the Learn Forge tutorial, you can see that we're going to be installing these 3 dependencies that I had mentioned earlier. You can type them one by one by using the install subcommand, or you can type them all together by typing npm install, and basically listing all 3 dependencies. So that's the Express, Multer, and the Forge APIs. And also, if you append, if you use the --safe, that'll switch. That'll basically mean that all these 3 new dependencies that you're installing to this folder, to this project, will also be recorded in the package.json file, right? So before I do that, let me just show that package.json for now is just a very simple piece of JSON, right? Not really providing any special information. But if I install all these 3 dependencies, Express, Multer, and Forge APIs, these will get installed to this folder, to this project. But since I use the --safe switch, these 3 dependencies, together with their current version as of now, will be recorded in the JSON file as well. So now if I look at the package.json again, you'll see that I now have 3 dependencies, Express, Forge APIs, and Multer, with specific versions defined, right? So the reason this is important is that when you, let's say, share this code with somebody else, you will not want to share all the source code of all the dependencies, right? You'll only want to share your code and this package.json file with that other person. And then the other person can simply run npm install without any extra parameters in that folder on their computer. And that this npm install without any other parameters will basically look at the package.json file, and it'll install all these dependencies that you have declared that your project relies upon. All right, now what are these? Like I said, Forge APIs, that's the Forge SDK, right? So that's a software development kit for Node.js, so that if you want to interact with the Forge services, you don't need to build these HTTP requests from scratch, and you don't have to parse the HTTP responses all the way by yourself, right? You simply call your instance, you create a new instance of a class, and you call methods on that instance, and that will basically make these calls and parse the responses from Forge for you. Express is a popular, express.org, I think that's the address. Let's say probably one of the most popular web, maybe not this one, express.js.com. All right, it's probably one of the most popular web frameworks for Node.js, allowing you to quickly and simply build Node.js server applications. So that's what we're using here as well. And the Malter, this last dependency used here, as I mentioned, since our application will allow us to upload files to it, so that we can later send these files to Forge and translate them and prepare them for viewing in Forge Viewer. We'll also need some help to easily parse these requests that our client JavaScript code will make to our server, uploading a file, right? So that may be using a special content type. In this case, we're going to be using the multi-part form data. That's what it's called. It's a type of a content encoding form data. That's what it's called. Multi-part form data. Let's see if I can find it here. Yeah, multi-part form data. Right, so this is a way for you to basically make an HTTP request to some service, providing one or more inputs, which can be simple values or binary buffers like files, complete files. So we're going to be using this multi-part form data encoding to upload our files to our server. Okay. I see a question. Are there any Forge libraries for Python? Not official ones, as far as I know. I know that one of our customers have been building their own Python SDKs for Forge. So let me see if we can find those. I believe they made those available. I don't see them here. I believe they were available on GitHub. But no, I probably need to take a look. I'll try and see, look after this session to see if I can find it. I know, again, yeah, one of our customers built their Python SDKs for Forge as well, so that you don't have to make the HTTP requests from scratch in your Python application. To see which languages we support, I would maybe also just mention it here. If you head over to github.com/Autodesk-Forge, this is the official GitHub organization where we provide most of our samples as well as the SDKs, right? So for example, if I search for Node.js or Node, right, you'll see that we have some samples for Node.js as well as here, for example, Forge API Node.js client. That is exactly that NPM dependency that we've installed to our project, right? So we can see if we look for Python, there might be some tutorials, but yeah, unfortunately, an official SDK for Python we do not provide as of now. That may change in the future, though. Yes, and I see. Yes, my colleague Varun mentioned one and posted a link. I believe that's actually my own thing. I started building how this SDK for Python could potentially look like, and so this Autodesk-Forge-SDK and the Python package index, I believe that's mine. That's like a start for how such an SDK might look like. So you could use that as an inspiration, and maybe, because I think it does provide some basic methods, access to some basic services. So you could take that as a starting point, basically, if you wanted to as well, and maybe add your own, support for additional Forge services there. All right, so Malter again is a plugin for Express for the web server framework that we're going to use to handle the multi-part form data content type when our client-side code is uploading files to our server. All right, that's it. Now, you should probably just see package JSON with potentially this package lock JSON. That's an auto-generated file that just keeps track of the specific versions of all the dependencies and their nested dependencies. Node modules is a folder where all these third-party dependencies have been installed and are ready to be used. All right, now what I'm going to do is I'm going to go back to our Visual Studio Code, and I'm going to simply say open. I'm going to navigate to that folder that I created. In my case, it's called day one. And I'm going to open that folder because in Visual Studio Code, that's basically how you open your project, right? You don't have any custom like solution file. In VS Code and typically in web development world, you just open a folder and that's your project, right? So now we've opened, I opened the day one folder that I had created. So that's my project now. I can see my package JSON with the 3 dependencies, right? And I can see this auto-generated lock file that keeps the track of the specific versions of all the complete tree of dependencies and their dependencies and their dependencies, and the module folder. All right. Now, as we mentioned, for those of you using Visual Studio Code, I would also recommend that you create a new launch configuration. You can do it a couple of different ways. We can either create this helper folder manually. So VS Code stores all its information in a subfolder called .vs Code. So we could create it here by hand, or what you could do is if you simply navigate to this run and debug section in VS Code, right? This is where you will eventually run your application in the debug mode. But now it hasn't found any launch configurations yet. So it's wondering, if you would like to create a launch JSON file. If you use that option, it'll ask you what language you want to generate the configuration for. So in our case, it's going to be Node.js, right? So we can use one of these, and it'll create this launch JSON file. You can see here in a folder called .vs Code. So here is where the Visual Studio Code editor is going to be looking for all the different modes, configuration modes in which you may want to launch and debug your application. What I'm going to do is I'm going to head back to the LearnForge website, and I'm just going to copy the whole thing and replace the content of the auto-generated launch JSON file with it. Right, so it looks very similar. Basically, at the top level is a JSON object with a list of a property called configurations. This is an array where we can keep adding the different configuration modes in which we may want to launch our application. So for now, there is just a single launch configuration. We gave it some name. In this case, we named it launch program, right? We asked it to, it's of type node. So in this case, this launch configuration means we want to start a Node.js application. With the program property, we say which file we want to run with Node.js, right? And we can even specify environment variables to be passed into the Node.js process. That's basically it, right? And then with the launch JSON file created, if I go back to the run and debug section here, you'll see that I already have my list of configurations, for now just one, called launch program. I can add more, but this is basically how I can now run the app, put breakpoints inside my code, and have the code execution stop at that point and investigate the state of variables, etc. Okay, so I have my launch configuration ready. Now, what I'm going to do is I'm also going to copy and paste my Forge Clan ID and Forge Clan secret here, because again, when we run our app, we will want the app to be able to authenticate itself against Forge, or to Forge in some way, right? And ideally, that would be with the credentials that Forge created for us for our new Forge application that we created on the portal website. Let me go back to my app on the forge.autodesk.com, right? This is my new Forge application that I've created for this event this week. So once again, I'm going to copy and paste the client ID, paste it here, and the client secret as well. Now we use this Forge callback URL. That's something that we're going to be using tomorrow for the login workflows, where we will basically ask our users to log in with their credentials to Autodesk servers. And if Autodesk confirms that, yes, these credentials are valid, the users will be redirected back to our app. And Autodesk needs to know where exactly the user should be redirected to after they log in successfully. So this is something we can keep it here. We're not going to use this environment variable today. We're going to be using it tomorrow. All right, so I've got my Forge client ID, Forge client secret ready. And what it means is that in my Node.js code, I can now, instead of hard coding any credentials into the code, which is not a good idea, right? I can instead retrieve any input parameters from the environment through these environment variable. And if you need to pass more parameters, you can just keep adding extra properties here. And all these will be available to your Node.js application as environment variables. All right. It's our launch config, and we can move over to start building our application. So we're going to start by building our start.js file, right? That's going to be the main entry point to our app. That's where we're going to define the Express.js web server, right? And where we're going to define all the different URLs that it can answer to, the different endpoints that it can handle. Now, let me just copy this for now. You could be typing it by hand, but I think it's probably going to be better use of our time if I just take this code and explain what it does. So at the root of our project folder, I'm going to create a new file called start.js. I'm going to paste that content in it. And now let's briefly go over what this is doing. All right, so we start by bringing in some dependencies, right? This is a way in Node.js of like importing modules into your script file. So in this case, we're importing some path module, which is built in, available in the standard library of Node.js. And we're bringing in this Express. That's the web framework, popular web framework for Node.js. So we're importing that module into our code. Next, what we do is we try and read the config.js file, which does not exist yet, but we will create it soon, right? So apart from importing third-party dependencies, we can also use the require to bring in, to read in another JavaScript file, a module that we have in our own code base. So we're going to try and read this config or config.js file. This is the same thing. You can just leave out the JS extension. And we're going to check if that config, the module that we imported from that config.js file, if it contains some property called credentials, and if that property, that object, contains client ID and client secret properties in it. And if not, we basically do an early return, right? We just complain to the console, say, oh, by the way, you probably forgot to provide your environment variables, the Forge client ID and client secret, and we return immediately without doing anything else. But if these two properties are provided as expected, we simply create a new instance of our Express server, and we start defining something called middleware. So this is basically a way for a web server for you to define how it can handle incoming web requests. So you can basically build a stack of different functions called middlewares that may or may not react for certain incoming web requests, right? So in this case, we are adding a couple of middlewares. We're basically saying, okay, so here's one option. When we receive a request from a browser for some URL, let's say /image.png, this middleware, what we're doing here, this Express static, it'll try and see if that image.png file perhaps happens to exist in our public subfolder, which we don't have one yet, but that's where we're going to place all our client-side assets like HTML, CSS, images, and JavaScript, and etc. Right? So this middleware will basically try and see, okay, so the user is requesting a file, image.png. This code, this middleware will try and see if that image.png is available in that public folder. If there is one, it'll respond immediately to the client without bypassing all the other middlewares, right? But if it does not file any file, if it cannot find any image.png file in the public folder, it'll basically just say, okay, I skip, and it'll let the execution go to the other middlewares that, again, may or may not react to this request. On line 13, this is a middleware that we use to basically ensure that if the incoming request states that the content type is JSON file, this middleware will basically parse the JSON body for us automatically. And we also provide some additional config options, for example, limiting the payload of the JSON that we want to handle to 50 megabytes. So if somebody tries and sends us a JSON that's 1 gigabyte, this middleware will basically respond with an error saying, oh, by the way, you're sending us JSON, but it's too large. And the next three middlewares, this is basically, we're going to be defining these routers, this additional logic to handle our custom endpoints on the server. We're going to get to these in a moment. And finally, there is a catch-all middleware where we basically say if no other logic was able to answer an incoming request, that incoming request is probably not valid, right? So we're going to respond with, we're going to output some error to our console, and we're also going to respond back to the client with an error message in form of a JSON structure saying, okay, maybe you made an invalid request, maybe there was a wrong parameter somewhere in it, something like that. So this is the catch-all for handling unrecognized requests, basically. And finally, running app.listen basically means we want to start our Express.js server application listening on a specific port. As you can see on line 4, it basically means either any environment variable called port that was defined, maybe contains some number of a port that we want to listen on, or we default to 3000. That's it, right? Now, if we tried running this app, it wouldn't work because, of course, now it'll try and read some config.js file and some OAuth OSS JavaScript files, which don't exist yet. So let's not do that for now, but let's move on to specifying the config.js file, which is, again, where we're going to be reading all the inputs we need from the environment. So again, let me copy the contents of this config.js, create a new file in the root of our project folder called config.js, and paste the content into it. So basically, what we do here is we just specify this module.exports as an object, JavaScript object. That's basically a way for Node.js, for one file in Node.js, to expose some symbols or classes to another Node.js file, right? So that the other file can require or import this content with the require function. So here what we say, we are exporting an object that has two properties, credentials and scopes. Credentials, this is where we are reading the environment variables through process.env. So process is a built-in variable in Node.js that gives you access to process arguments, environment variables, and all that information of the running process where your Node.js script is currently hosted, right? So process.env gives you an access to a simple dictionary JavaScript object where properties are names of different env variables and values are their content, right? The environment variable values. So we simply try and read the forge client ID and forge client secret and forge callback URL from the environment, and we're storing these in this credentials object, right? And if I go back to my start JavaScript file, here is basically where we try and read that object, right? With this line, this config constant will basically be this JavaScript object. And we check, once again, if credentials client ID is defined and if credentials.client secret is defined. And if not, we know that our application cannot run, right? Because we don't have the information we need to, specifically the credentials, so that our server app can authenticate itself to the Forge platform. All right, so that's our config.js. And then in the scopes property, we also define a couple of scopes. And scopes are a concept in the authentication of Forge, because Forge uses a token-based authentication, which means that when you want to interact with the Forge platform, you need to request a specific access token, which is a long string. that contains, that basically is only valid for, let's say, 1 hour. So it has a limited time to live. And with that token, you can then communicate with different parts of the Forge platform with different services. But now to make the control and the control management more granular, when generating a token, you can choose to decide to define a list of capabilities that that token will have, right? So when you're creating one token that maybe you want to share with your client side code, you probably don't want that token to be very powerful, because if somebody for any reason somehow was able to steal that token, that could potentially be used by some malicious code, right, to do something you don't want. So typically, if you are generating an access token that you're planning to share with the client-side code, you can only give it some very limited capability. So that, for example, that token can only read the translated files from Forge, right? But then, of course, when you need to handle some more logic on your server-side code, and maybe you know that you will need to create new files in Forge, rewrite files, delete them, right? In that case, you can generate a different access token that will have more capabilities, and that token you will only keep in your server side, but that token you will not share with the client side code, right? So you will basically secure any write access to your application's data so that nobody else can really access it. And that's exactly what we're doing here in our config.js file. We are specifying one set of scopes called public. This is, and this list of capabilities we're going to use when generating a token that we will be sharing with the client-side code. And here we basically say the only action that that token will have is viewables column read. So that token will only be able to read translated files from Forge, specifically from the Forge model derivative service. And then we're also going to be creating a separate access token that's only going to be used internally by the server. And that one, of course, will need to be able to do more, because our app will need to create new buckets. These are the folders in the data management service. It'll need to be able to read or take files, etc. Right? So that's the list of this property called internal. That's a list of scopes that we're going to be using to create our internal access token that we're not going to share with anyone. Okay, that's for our basic server. Now, before we move on, let me just quickly create two folders, for now empty, that we're going to be using later. As you saw here, right, on line 12, when we define this static file serving middleware, we will want that middleware to look into a subfolder called public to see if there are any files that the request may potentially be asking for. So let me create a public folder here. Now we're going to leave it empty. And eventually in session 4, we're going to populate it with the HTML client-side user interface. And also, as you can see on lines 14, 15, and 16, when defining the custom logic for the server, the different server endpoints that it'll be able to handle, these will be imported from different scripts under a subfolder called routes. So let me create a routes folder here as well. For now, again, it's empty, but eventually here's where we're going to be defining different JavaScript files that will handle different types of server requests. Okay. That's it, I believe. And with that, we can move on to the authentication step, right? That's the second step of our view your models tutorial. And again, we're going to choose Node.js, right? Because we're building our application in this language. And here's what we're going to do. We're going to start by defining this Oauth.js file under our routes folder. So let me copy the content. And inside the routes folder, I'm going to create a file called oauth.js and copy the contents from the Learn Forge website to it. Okay. Now, what's happening here is we're building a router from the express third-party dependency. Now, router is basically a collection of endpoints that are handled in a certain way. And the router itself is basically meant to be mounted to certain URL prefix, basically. So you can see here, what we do is we say that the router will be able to handle a GET request to some URL, but in this case, we just say /token. But take a look at what we're doing here. We're exporting this router object, and our star.js file, this is where we are importing this router, and we are mounting it, quote unquote, to this prefix, /API/forge/OAuth. And what that means is, since we took this router and mounted it to this prefix, this code will be executed whenever somebody makes a request to our server with the complete URL, the /API/forge/OAuth. That's the prefix that we mounted our router to. And then if it's going to be followed by /token, right, that's where this specific function will kick in and handle that incoming request. This is done so that in some cases you may have a single router attached or mounted to to multiple different prefixes, right? So the same logic will be handling different types of URLs. And inside here, what we're actually doing, if somebody makes this GET request to API Forge OAuth token, is we basically call a function that we haven't defined yet. We're going to build it. We're going to build this one next. We're going to have a helper function called getPublicToken that will request that Forge token from the Forge authentication service. And when it's done, by calling res.json, we will basically send a response in form of a JSON containing two properties, access token and this, some number defining number of seconds during which the token will remain valid. Right? And then some code on the client side will be able to make this request to actually retrieve this token. That will be the viewer. We'll cover that in the session 4 today. All right, now for the helper function. We will have a couple of helper utility functions for authentication, and we're going to store those under a common subfolder inside the routes, right? So inside the routes folder, I'm going to create another subfolder called common. And inside here, you can see that we're trying to basically import another JavaScript file from the common subfolder called OAuth again. So I'm going to create another OAuth.js file inside the common subfolder. And the content of that file, again, I'm going to go and copy from the Learn Forge website. And again, I'm going to quickly explain what this code means. Okay, so here is where we're finally using the Forge SDK, the Node.js SDK, right? We're importing that module. And this construct, having these curly braces on the left side of the equal sign, this is a destructuring. So we're basically importing the whole object, JavaScript object, which can potentially contain many different properties or symbols. And we're only cherry picking one from them called auth client two-legged. So this is a class that we're going to be using to handle any two-legged authentication in Forge. Now, just a slight side note, now is probably the right time to mention that the authentication in Forge works in two ways. It can be two-legged or three-legged. And then this number of legs basically means the number of parties that need to establish trust between themselves. So in case of two-legged authentication, that's the standard basic one. That's where basically it's just the Forge platform and your server application that need to establish trust. So your application needs to prove that it is who it's claiming to be. And then that's going to be the topic of day 2 that we're going to be working with user logins. There's the three-legged authentication where the third leg, the third party, is the user, right? So they establish the trust between your Forge app, the Forge platform, and your application's user. So for now, we're just using the two-legged authentication. So we're just going to use this auth client two-legged class. And what we do is from this JavaScript file, again, using the module of exports, we export 3 helper functions, one called getClient, that simply returns an instance of this auth client two-legged class based on the scopes that we need, right? That's going to be the input to the get client method. And then it returns the get public and get internal token functions. And as I said earlier, these are just helper functions that will generate a token for the specific set of scopes. So if we call get public token, it will automatically know that it'll try and request a token using just the public scope. That's just the viewables read, right? So that access token will not be able to do anything else but reading some translation outputs from forth. And then the internal one, the internal token, that one has the additional capabilities, right? That one is able to create new buckets or create new files or delete files, for example. So these are the helper methods or functions that we export from this JavaScript file that we will then use in other places in our server-side code. And the first one is the Oauth Router, right? Where basically, again, when somebody makes a get request to this URL, API forge Oauth token, we will call the helper method to generate a public access token, and we will return it to the user. All right. And that is it for our authentication logic. Now, again, if we tried running the app, we can try it from, because we have our launch configuration in Visual Studio Code defined, right? So we should be able to run it from here, but let's see what happens. If I hit F5 or I hit, I see that the process exited with code 1. And the reason is it couldn't find a module called route/OSS, right? And this is basically coming from our server definition where on line 15 and 16, it is trying to import some Express.js router from a file called oss.js under the route folder, but we haven't defined it yet. And the same would apply to this model derivative module, right? So what I'm going to do for now is I'm going to comment these two out, and we can try this. Now, if we run our application again, now you see it's actually running, right? So we got the message from the last line of our start.js file where it says, okay, the server is now listening on port 3000 on localhost. So what that means is that I should now be able to open my browser and go to http //localhost 3000. But again, if I do this, I'm going to get an error. And this is the catch-all mechanism in Express, right? Because the server currently has no way of handling this request to just localhost 3000. Or if I say foo/foo, right? I mean, the server doesn't have any logic. It doesn't know how to answer to that request. So it's going to say, cannot get foo, right? I don't understand what you're asking for. But if we look back at our implementation, if we look at the Oauth Router, you can see that now there is one endpoint that the server should be able to answer, and that's the /API/forge/OAuth/token. So let's try that one. I'm going to copy the URL, bring it back to my browser, and use it here. And there you go. See, now what happened is this one endpoint, our server application can actually understand. So it handled that with this little function. And now let's try one more thing. Let's put a breakpoint, let's say at the line 10 here, right? And let's go back to our browser and reload the page. And now, since we're running the application from Visual Studio Code using the launch configuration, we can actually debug it, right? So now we've intercepted, stopped the execution of the code. I can check the, I can check the state of the different variables. I can step, let's say, inside the get public token method, right? So I can see that, okay, it's going to call get token. And you may see this weird native code. That's because of the async code. So if you run into like this async hooks.js file, you can simply step out of this function. And now you can see that we're inside the get token function here. Now, why do we need this custom special code, right? It's a good practice to cache tokens for the time they're valid, right? So if from the browser, if I ask 100 times to get an access token, if I make that API forge OAuth token request 100 times, the server application, it wouldn't be good if the application kept making new requests to forge and again and again and again, right? So what we'll do here is the purpose of the get token function is to cache a token for a specific set of scopes. You can see that's what we're doing here, right? So we take all the scopes that somebody is trying to token for. We see that there is just one, the viewables read, and we turn it into a cache key, a string. In this case, it's just the scope itself, right? We just connect them with a plus sign if there's more of them. And now we check our cache, which is just a JavaScript map object, right? Does it already contain a cached value access token for this key? And if it does, is the expiration time, is it expired or not, right? And if not, we return this cached access token without actually making any requests to forge again unnecessarily, right? So here's how we received our token data, right? So it contains the token itself, some information about when exactly it expires. That's the Unix epoch time, and the number of seconds in which it expires. And then we simply return the access token and the expires in as these two properties of the JSON. That's what we send back to the client, and that's what we see here. All right. And that is it for the authentication step. And that's it for session 2. So now it's your turn again. So again, what you'll want to do is initialize a new Node.js project using the Npm Init command and install the 3 dependencies, right? That's the Express for building server applications Node.js, Multer, that's something we're going to use later to handle uploads, file uploads. And the third dependency is the Forge-APIs. That's the Forge SDK for Node.js. And again, if you happen to be using Visual Studio Code, I'd recommend defining your launch configuration in the launch.json file under the .vs code folder. And then start building your server. So again, prepare the start.js file that contains your Express server definition and the config.js, where we collect all the input from the environment, right? In this case, it's the 2 environment variables, Forge client ID and Forge client secret. And finally, so you can start building the Oauth router under the routes folder that will handle the first type of endpoint, right, to generate the public access token. Okay, and with that, you're now free to follow these steps, and we're gonna meet back here in roughly 1 hour and 12 minutes to look at the session 3 that's going to be adding logic to our server for uploading and translating files. And again, if you have any questions in the meantime, feel free to ask in a Q&A or in the chat. I'll just go grab something quick to eat, and I'll be back here monitoring, answering your questions. All right, thank you, guys. All right, welcome back to session 3 of our day 1 bootcamp today. Now is the time to start updating our server, adding support for uploading files and translating files for viewing, for later viewing in Forge Viewer. Now, before we move to the implementation, let's again take 1 or 2 minutes to see if there are any pending questions regarding what we built in step 2. Maybe while waiting, there was one question, some clarification needed on the promises, the concept of promises and async await. So very briefly to touch on that. So promises are something like tasks in C#, and the concept of async await is a really powerful thing when you're dealing with asynchronous code execution. That means calling code that cannot give you any result immediately, but calling a method that could eventually give you some result or that could eventually fail, right? That could be, for example, a method that needs to make a request to a server somewhere, right? Because that may take time and you don't want to be blocked waiting for the response from the server to come back, only for your method to finally give you some result. That's why different programming languages introduce these async features. And again, in Node.js, these are called promises. In C#, they would be called tasks. And those are basically objects that encapsulate some result that could eventually be available or a result that could eventually be rejected due to some error, for example, right? And that's basically what we're doing here in our Node.js server. And that's one of the reasons why we recommended that if you're using your own version of Node.js, then that's fine, but it should be at least version 10. And that's precisely because of the async await features. So that's what you see being used here, right? So if we look back at our getPublicToken method from our common/OAuth.js file, getPublicToken, this is actually an async function. So in Node.js, that means that this method will not give you any token immediately, but it will return something, a promise, that will eventually, sometime in future, be either resolved with some actual token or rejected if there was some error, maybe if your forged client secret was incorrect. So simply by declaring the function as async, Node.js will already return any result from this method or function as a promise. And on the other side, on the receiving end, or on the side of the caller of this function, here we call await, which means we want to actually wait inside this function. We want to wait before proceeding with the further execution of the rest of the code here. We want to wait for this promise to be resolved, right? So you can see if I hover the getPublicToken function, Visual Studio Code is already smart enough to detect some kind of return type from our getPublic method, right? So here we don't really specify what type of object is returned, but VS Code does know that it's an async method, so it's going to return a promise of some kind. And because of that, we are using, otherwise, if we were not using the await and we simply called getPublicToken, this would return not the token itself, but some kind of promise. And then the promise object itself provides some additional methods like then, finally, or catch. And these are the methods that you could use to actually provide some additional code that could be executed later when the promise is finally resolved or rejected, right? So then would be a good example. So if you call promise.then, this is where you can specify any kind of code that should be executed when the promise is resolved successfully, right? And so you're basically passing in a function, a callback function, and that function receives the value of the promise as its only parameter. So we could say, we could insert a function that, let's say, just outputs the token in the resolved promise to the console, right? And you could also say, well, if something goes wrong, I'm going to receive some kind of an error message. Maybe I'll do something with it as well. Right? Maybe I will output the error in the error console. Right? And typically you chain these like this, right? So I could say, okay, I'm waiting for some promise. So the getPublicToken method function promises that eventually it will either return some kind of a token, or it will fail with some error. And this way I can handle both of these situations. So that's a little bit to the async await and how we work with the async methods from the Forge SDKs in our server application. All right, I see there are no other questions, so we can move on to session number 3 again, and that will be extending our server, adding support for uploading objects, meaning files, design files of your own, and getting a list of objects available already in Forge, as well as starting a translation of our designs for viewing in the browser. So here we finally start touching on some of the components of the Forge platform. In session 2, we only use the authentication, right? So we use the two-legged OAuth client class to just make a single request to Forge to generate an access token based on some input set of scopes. Now we're going to be adding we're going to be using more of the classes from the Forge SDK, and we're going to be making requests to some of the other services in Forge. One of them is the data management service, and maybe let me quickly bring it up here in the browser. I'm going to head over to the Forge portal, to forge.autodesk.com, and I'm going to head over to documentation. All right, and here, one of the services, so for now, we've only been using authentication, but now let's take a look at data management. So that's one part of the Forge platform that allows you to manage your data inside the platform. To allow to upload objects, delete them, or get a list of objects available in a certain bucket, for example. So that's what we're going to be using now. That's the OSS part. It stands for Object Simple Storage. So that's basically like your S3 in AWS, in Amazon Web Services, right? So you have these top level sort of like folders called buckets. They cannot have any subfolders. It's really likely just for top level separation of data. They have to be globally unique. So when you're coming up with your own bucket name, you need to make sure that it's globally unique. Otherwise, you may end up with a response 409 saying, okay, the specified bucket name or key already exists. And then you have different APIs for working with objects, or in other words, files in these buckets. You have a standard put endpoint for uploading an object. You have, for example, a get buckets /objects endpoint to get a list of all objects stored inside a specific object, a bucket. That's something we're going to be using in our app as well, right? Because as we're showing eventually in step 4, as we will be adding the sidebar with a preview of all your files you can view, we will need to retrieve that list of buckets and the files inside each bucket in some way from our server application. So these are the methods we will be, the endpoints we will be using in our code, but instead of making the HTTP requests to these endpoints manually, we're going to be using the Forge SDK to have, again, a little less typing to do, basically, and higher level of abstraction. So that's what we're going to be using now for the data management. And then next, for actually preparing one of the designs that we've uploaded for viewing, we will need to use another service from the Forge platform. And this one is called Model Derivative Service. And that one is responsible for basically taking your designs that are sitting in Forge and extracting all kinds of metadata from it. And by that, we mean things like thumbnails, 3D geometry, 2D drawings, and most importantly, really, also all the different metadata attached to the individual elements of your design, right? So if you have a 3D model or a 2D drawing, that typically consists of multiple different elements, and these elements can have their own metadata, their own properties that you may need to use in some way in the future. So the model derivative service from the Forge portfolio is the service responsible for extracting all this information for you and making it available to you either through another set of endpoints, server-side endpoints like these. So for example, for a given model, you can request the properties of a specific object or properties of all the objects in the model. Or you can then access all this extracted metadata from the viewer. That's what we're going to be leveraging heavily on day 3 when we talk about the viewer customization and building dashboards and that sort of thing. Okay, so let's add couple more routers to our server-side application. It's demo time. If you look back at the LearnForge tutorial, now we're basically moving over to the upload file to OSS. We're going to be adding our Node.js code. So we're going to be adding another router in a file called oss.js. That's the object simple storage, right? Because we're basically preparing a router that will handle any data management. This file is a bit longer, so once again, let me copy it and add the code to our new project and then explain what it does. All right, so under the routes folder, we're going to create a new file called oss.js where we can paste code, maybe. All right. And now, what this code is doing, let's take it step by step. Now, as you can see, we're now importing additional classes from the Forge SDK. And this time it's classes like Buckets API or Objects API. These are typically used to access the different groups of endpoints from the different Forge services. In this case, we will want to be able to create a bucket or get a list of buckets. So we're going to be using the Buckets API class of that. And then we're also going to be able to, we want to be able to get a list of objects in a bucket or upload new files to the data management service. So we're going to be using the Objects API class for that. Okay, and once again, just like when developing the authentication router, we're again using a helper function from the common OAuth JavaScript file. But this time we're not using the get public token, right? This time we want to generate a token that we will only be using internally to do things like creating buckets, uploading files, etc. So that token needs to have more privileges. So we're going to be generating this one with the longer set of capabilities or scopes. But this one we're only going to be using internally in our server, not sharing it, not exposing it through any endpoint. All right. Now, what do? We again define an Express.js router. And here we basically implement a middleware that's going to be applied to every single request coming to this router, right? So no matter whether that request is going to end with the URL, whether it's going to end with /buckets or whether it's going to be a post request to /buckets or whether it's going to end with objects, we're always going to run the request through this little piece of code, no matter what. Right, so this is really helpful if you want to have some common shared piece of logic that is applied to every incoming request, and then that can then be handled by the specific middlewares that actually respond to the request. Here, what we do is basically for every incoming request, we simply generate an internal access token, right? And we store it in these two properties on the request object in memory, so that whichever code handles the request later will have access to these two, right? So we store the token itself, and we also store this OAuth client. That's the actual instance of the Forge SDK class that's used to generate the tokens. All right, and then we define a couple of different endpoints, right? So in this case, we're defining a handler for a get request to something /buckets. Again, right, as we discussed in the previous session, the final URL that this code will handle will depend on where you mount the router, right? And in our case, if I look at the start.js, our server file, you'll see that the OSS router will be mounted to /API/Forge/OSS. So in this case, if we're listening for get requests to /buckets, the complete endpoint that this code will handle is this /API/Forge/OSS. It's a mouthful /buckets. All right. Now, what does it do? First of all, we check if any query parameter has been applied to the URL. And we're looking for a query parameter called ID. And query parameters are the parameters that are typically at the end of your URL after the question mark, right? So we check if there is any parameter called ID. And if there isn't one, or if that parameter is just set to a hash sign, we basically expect that the client is asking us for a list of buckets. So in that case, we simply create a new instance of this buckets API class from the Forge SDK, and we call getBuckets function, which under the hood, again, will simply prepare an HTTP request and send it to the proper endpoint of the data management service in Forge to get the list of buckets, and it will parse the results for us as needed, right? And it's an async method again, so we are calling await so that this code will basically stop here and wait until that promise is resolved or until it fails. And in the meantime, other code in Node.js can run. All right, so we get the list of buckets, we limit it to 100, and then when ready, we basically cherry pick the items, that's the bucket objects or descriptions from the response of the body. And we turn all these bucket objects, we basically extract their bucket key, and we turn it into a custom JavaScript object that has these properties: ID, text, type, and children. So we're basically just returning the same list of buckets, but in a slightly different format with, as JavaScript objects with slightly different properties. And that is because, we're basically preparing this JSON in this format so that later on, when we build the UI, so that we can easily consume it in the tree view component, right? Because the JavaScript component that we're going to be using in the last session today, it expects data to be structured in a specific way, right? It expects JSON with objects that have these properties: ID, text, type, children. So that's why we're basically reformatting the JSON as we're sending it back to the client. Now, if we do receive some ID query parameter, we expect that it's a name of a bucket that we should return the contents for. Right, so in that case, in the else branch, we say, okay, well, in that case, we create a new instance of the objects API class from the SDK, Forge SDK, and we return not objects, but we list all objects in a specific bucket, right? That's the value we got from the query ID. And again, we limit the number of results to 100. Here is where we pass in the token and authentication client that we stored in our generic middleware here. And again, on the response, we return a JSON with, specially formatted JSON objects that we will then be able to easily consume within the tree view component when we start building the user interface. And that's it for our get buckets endpoint. Now, we provide another one, and here you'll notice that we are saying router.post instead of router.get. This means that we're defining some logic that should be triggered when somebody makes a post request to some endpoint, right? And again, the final URL you'll find out by taking the prefix to which this router is mounted plus this rest of the URL. So the complete post request will have, this function will handle post requests to this complete URL /API/forge/OSS/buckets. And in this case, what we do is we will want to create a bucket when somebody makes that request to us. And to that, we use, again, the buckets API class and a method called create bucket. Now you'll see that, in the SDK, it comes with some signature definition and IntelliSense in VS Code here. So when you simply hover the method, you'll see the different parameters that should be provided. So in this case, since we want to create a bucket, we'll need to provide some more information, like what should the name of the bucket be, and for example, what the data retention policy should be. And that basically means how long do we want to keep the data in this particular bucket. So you have three options. You can either say transient, which means, as the comment says here, that the data will be removed in 24 hours roughly, automatically. Or you can set it to temporary, which means that any data in this bucket will automatically be cleaned up after roughly 30 days. Or you can set it to persistent, which means that data in this bucket will never be cleaned up automatically. So you can then delete the data when you want to. All right, and then we basically send this payload, this name of the bucket and data retention policy as the first parameter to the create bucket method. And again, passing in the access token, right? Because again, when you want to make a request like this to Forge, you need to be authorized to do that. And that happens through the access token that you have generated for yourself with sufficient scopes or privileges, in other words. Okay, that's what this post endpoint is going to handle for us. And finally, we have a post request to /API/forward/OSS/objects. And this is going to be a post request where we're going to expect the client to call when they want to upload a new file to Forge. And this is where we finally start using this third NPM dependency that we installed at the beginning of this webinar, right? So we installed Express, Forge APIs, and the Multer plugin. We're importing it here as usual through the require method. And if you look at the documentation for this plugin, you'll see that basically all you need to do is call Multer with a couple of parameters, and that will generate a new middleware for you. And you can actually combine multiple middlewares even in individual router.get or router.post or patch requests, right? So what we say here is whenever somebody makes a post request to this URL, we will first run that request through this middleware from Multer, right? And here what we basically say is Multer will take a look at the content type of the incoming request. And if it's multi-part form data, it will read all the fields, all the files, all the content from the request, and it'll make it available to us on the rec object later on, right? It will not respond to the request immediately. It'll just parse all the information from the input, make it available on the request object, and pass it further so that our code here can actually react to that request. In this case, what this part says, what this part means is basically, I want to see if there are any files coming in named file to upload. And if there are, I want you to save that file temporarily into an uploads subfolder in our project. And then what will happen is in our own code, if we take a look at rec.file, this file property is not usually there. That's not a standard property of the request object, right? But since we are using this Multer middleware here, this rec.file property will be available if somebody made a request to us with some file included in the request. And that file, should be named file to upload in this case. So what we do in our own code here, we basically read the file from its path that's going to be somewhere under the upload subfolder. And when the file is read into memory from our uploads subfolder, we will basically use again the objects API from Forge SDK to upload this object to our, to a specific bucket under a specific name. And again, we need to, of course, use the proper access token for it, right? So that we prove that we're authorized to create new file or overwrite an existing file potentially. Okay, that is our data management router. That's all this is doing, right? So listing objects or listing buckets or uploading objects to a specific bucket. And you can, as you can see here, the bucket key to which the file should be uploaded to, we are retrieving it from a body of the request, right? So the request may actually contain multiple things. We expect that it will contain a field called file to upload, which will actually contain the contents of some file that we're uploading. And we also expect the incoming request to contain a field string called bucket key, which should include the name of the bucket into which we want the file to be uploaded. All right, that's for the OSS router. And finally, let's look at the translation. Again, we're going to choose a Node.js version of the tutorial. And this is the content of our model derivative JS file under the routes folder. So let me again copy it and create a new file under routes, call it model derivative.js. Copy the content here. And let's take a look at what we're doing here. Again, we are building a router, right, that we will eventually mount to some prefix. And we're again using the helper method for generating internal access tokens. That's something we're going to need, again, to be able to trigger a conversion job in the Forge model derivative service so that it starts extracting all the information from a specific file for us. All right, once again, we use the same middleware so that every request handled by this router, we will prepare the internal token on this OAuth token property on the request object so that we can later on use it as whenever we need to. And the router will be mounted, again, if we take a look at the server definition, it'll be mounted to this prefix /API/forward/model derivative. In this case, it's up to you how you decide to name your URLs, right? How you to structure endpoints. In this case, we just happen to use the convention of always start with /API/forge, and then this router specifically will be mounted to this model derivative subpath. So the whole thing, if we have a logic here for post request to something /jobs, this code will basically handle any post request to this complete URL /API/forward/model derivative. That's the prefix we're mounted to, right? /jobs, because that's what we specify for this handler itself. And when somebody makes this request, we expect that in the body of that request, we expect that it's going to be a JSON payload, right? And since we use a middleware here called express.json, the JSON body will already be parsed for us. So any property inside the JSON will be made available on the request.body object. So here we can simply, we don't have to worry about JSON anymore. We just say reg.body.object name. And by that, we will get the object name property from any incoming JSON. And we basically create an instance of another class from the Forge SDK, in this case, model derivatives, and we call the translate method. This one expects a payload specifying what files or which file specifically we want to translate in Forge and what outputs we want to generate out of it. In this case, we're saying that the input for our translation job should be this object name. That's something that's going to be provided on the inside the HTTP request made to our server. And we're specifying here that on the output, we want to generate an SVF file. That's basically a proprietary format for efficient viewing of your 2D drawings or 3D models on the web. That's a format that can be, it's basically a native format for a Forge viewer. And we're also specifying that we want to extract both 2D drawings as well as 3D geometries out of that particular file. All right, and that's it, right? Again, we pass in the access token to this method. And if everything works well, if everything succeeds, we return simply an empty response with code 200, which means everything went okay. And if there is a problem, we call this next function, which is basically available on every router handler, which says, well, just, I wasn't able to handle this request correctly, so I'm just going to pass it along to whoever else might actually be able to handle this request and respond, right? But of course, nobody else is going to be able to handle this request, so this code will end up in this catch-all, and it will basically just output the error to the console and respond with the error message back to the client. So that is our new translation endpoint that we're eventually going to use in the user interface to explicitly trigger a translation of one of our uploaded files. Okay. So now let's see. Don't forget to uncomment the routers that we originally commented, right? When we wanted to test the app in the previous session. Right, so I've uncommented all of these here. in my starter.js file, and I'm going to try and run the app. All right. Let's see. I want to see my debug console. Everything is running well. Server is listening on port 3000. So let's try that. We head over to localhost 3000. We're still going to cannot get index, right? Because there is still no middleware or no way for the server to know how to respond to this URL with nothing, right? But now, you remember from the last time that we were already able to try this API/forward/OAuth/token request that is supposed to generate a public access token for us, right? That still works. But now we can actually try and experiment with some of the other OSS or model derivative endpoints. Now, the way they work, let me take a look. Okay, so we had the get request, right? And it was listening for this URL /API/forward/OSS/buckets. So let's try that. Oh, as you can probably expect, it won't really tell us a lot. See, it did return successfully, but it basically returned a JSON with empty array, which basically means we don't have any buckets yet available in our application, right? That's something we're going to be able to provide in the user interface later on. We're going to provide a way for you to right-click or create a new bucket and basically initialize the creation of that bucket from within the user interface. But now, actually, if you're curious, we could start an experiment with this already before we implement our UI. We could start experimenting with our data in Forge through the Forge extension for Visual Studio Code. Because if I come here to the Forge sidebar, the first segment that you see at the top, buckets and derivatives, this is actually where you can start creating your buckets as well without coding anything, right? So here what I can try and do is I can say, create a new bucket. And as I mentioned earlier, the bucket names must be unique, right? So if I do something like, if I try creating a bucket called test, I'm guessing that it'll probably fail. I'm going to choose the data retention policy, right? The same that you would be choosing in your code. So I'm going to say, okay, I want it to be temporary. So I want all my files to be automatically cleared up after 30 days. All right, and you can see that, oh, the request failed with status code 409. So that means, yeah, I cannot create a bucket called test because somebody else had already created that bucket. Right now, what if I try instead something like maybe Petr Broz -test? And that worked, right? So now I have my first empty bucket in the Forge data management service. If I try and expand it, there's not going to be anything there yet. But I can actually go ahead and if I right-click that bucket and any object really in the Forge extension in Visual Studio Code, you're going to get some additional functionality exposed there, right? So for example, here I can request additional details about the bucket so I know who owns it, when it was created, what the data retention policy is, etc. And I can also use it to upload objects, right? So here again, the code that we've just implemented that we're going to be testing in the final session for uploading files from our web application. We can even try before that, before we get there, we can try uploading objects through the extension. So let me see if I can find some sample file. Do I have any? Yeah, maybe sports car. I'm going to choose this file. I can choose the name under which that file should be available in Forge. So maybe I'm just going to say sports car with a dash. You can keep spaces there as well, but just to show that we can just choose a different name for it. Now we get a progress bar indicating how much of the file has already been uploaded to Forge. And again, under the hood, this is doing nothing else than just making HTTP requests to the Forge data management service to in this case, upload your file. Now, see, I'm already showing some additional actions you can take, but I'm going to skip this for now. So you can see that under our bucket, we already have a sports car DWFX file, right? For now, we can expand it, but we're not going to see anything there, any outputs, because we haven't really initiated any translation of the file. But before we do that, let's go back to our browser and let's try making this request one more time to /API/forward/OSS/buckets. Now you can see that, oh, we're now finally getting one output, one item in response, right? And it's the Petr Broz -test bucket that I've just created, right? And it's also coming in this right format, custom format that we will eventually use in the user interface for the tree view component. So we will probably want to, show some text, some label, right, in the tree view for it. We're going to say that, okay, it's a bucket, to show some custom icon for it. And we also specify that, oh, it's, we want to show like this expanding arrow next to it, because there's most likely going to be some objects inside that bucket. And now if you remember, the logic for this endpoint said that if there is a query parameter called ID, and if that is set to some bucket name, it will try and return a list of objects inside that bucket. So let's try that. So I'm going to say ID equals Petr Broz -test. And now you see that it actually returned this one new DWFX file, which is going to be an object. And it doesn't have any more children, of course, because it's like the leaf in the tree that we're going to be able eventually to select and load into the viewer. All right. Dun, dun, dun. So with that, I would say that is it for session 3, and we are ready to move to building our UI in the final session. That will take place in roughly 1 hour and 22 minutes from now. All right, so it's your turn again. Now it's your part to add the OSS router to your server application that will handle the endpoints for listing buckets, listing objects inside a bucket, and uploading objects. And also create a new router for the model derivative service. So that's going to handle that one request, one endpoint that's going to be used for starting a new translation of a specific file. Okay, and again, we will see you here back at 2 p.m. GMT. So that again should be roughly 1 hour and 20 minutes from now. And in the meantime, if you have any questions, feel free to use the Q&A or the chat. I'll try and monitor it and answer your questions there if needed. All right. Hello again. We're back for session 4, and before we get started, we can give people a couple more minutes to join us back here for the final session. Before we do that, there have been a couple of questions around the same topic. Sometimes people have been having issues seeing the buckets and files that they had created using the Visual Studio Code extension in their application. And in those cases, please note that this has to do with the regions, geos. If you remember, when we were configuring our environment for the VS Code extension, we were able to choose between the US and Europe, or EMEA regions, right? That's basically Forge's way of letting you choose whether you want to have your files stored somewhere on the US servers or somewhere in Europe. Sometimes this is required for, there might be some government restrictions and laws that require you to host your users' data in a certain geolocation. That's why we provide these options. And by default, the Forge SDKs use the US region. And one important thing to note is that buckets, while they must be globally unique, if you use the SDK configured for US and you try and list your buckets that are in EMEA geo, you won't be able to see them. And to show how that works, let's try something here. As I was mentioning at the beginning, when you're configuring your VS Code extension for Forge, you can specify multiple environments that you may want to use with your extension. So let's do that here. I'm going to go to VS Code Preferences, Settings, and I'm going to search for Forge. And this should filter some of the Autodesk Forge extension specific settings. And one of them is called Forge Environments. And this is basically the part of the JSON configuration where you can specify one or more Forge environments that you can then switch between in the extension. So I'm going to go to the JSON file, or settings JSON file. You can see that this is already the first environment that I had configured earlier. And this one, again, is using US by default. So what I'm going to do is I'm going to duplicate this environment. I'm going to call them US and EMEA so that I can easily differentiate between them. You can see that I have these two options, right? So I'm going to have two environments configured for my VS Code extension. Both are going to use the same Forge credentials, but one of them is going to be using the US region and the other one the EMEA region. Now, in order for this update to be applied, I think we're going to have to reload VS Code editor. So now what's going to happen is you'll see that we're using our US version, US environment, right? And I can see my bucket here. But now if I switch over to the EMEA, you'll see that the bucket will actually disappear from the list. And that is, again, because when you're working with the Forge SDKs, you always want to specify which region you want to work with. And for example, if you try getting a list of buckets using the US region, but all your buckets are created in the EMEA region, you won't get any results back. Right, so here in my EMEA environment, I'm going to create another bucket. And I'm going to call it maybe just like the other one, but I'm going to append EMEA to it. All right, my bucket has been created, right? So now I'm going to switch back to my US version, right? So here I can see my original bucket that I had created earlier. Now, if I run the app, again, you'll notice that when my app is running, even though I've created two buckets under this Forge application, I've actually created them in two different geos, and that's why I won't see both of them at the same time. All right, let's go back and we can go to localhost 3000. And now if I remember what the URL was for the endpoint we had, it was API/forward/OSS/buckets, right? So now let's see what will happen. See, so we only see one bucket, the one that we've configured with the US endpoint, right? So again, going back to the documentation for the Forge data management service, you'll notice that this is actually the case with many different services in Forge and with many different endpoints that, for example, when creating or listing buckets, right? Getting a list of buckets, you'll see that in this case, apart from, the access token that you would have to provide if you were making this HTTP request by hand, you can also provide some optional query parameters like the number of buckets that you want to, the limit to the number of buckets you want to retrieve, or if you're like paging through buckets, you could maybe provide a string prefix that of the first bucket you want to start from. But the important one here is the region. And as you can see, the default one is US, right? So earlier when we use the create a bucket option in the Visual Studio Code extension, right? We didn't really specify any other options. So the extension just decided to create the bucket for us in the default US region. right? But some of you in the Q&A were wondering why they cannot see their buckets. What happened most likely is that you have created your bucket or buckets in the VS Code extension for EMEA region, right? So the extension actually used this other value when creating the bucket for you. And then, of course, in our code, if we take a look at the OSS router, right, where we list the buckets, we don't really specify any custom, any actual region here. So it's using US by default. So in those cases, if you're confused as to, why don't I see my bucket when I'm making this request, please note that if I hover the get buckets method, you'll see that apart from the limit property that I'm passing into the first options object, you can also specify the region, right? So in this case, now, of course, if I go to the browser, I'm only getting the one bucket I created in the US region. But if I wanted to maybe switch to Europe or the EMEA, all I need to do is just specify, I believe, lowercase EMEA region here. And now if I reload our server application and run it again, you can see that now I can finally see the other bucket that I created in the EMEA region. So I hope that explains that issue that some of you ran into over the break. All right, so with that, let me stop the app and go back to our slides. So again, we're now at the final session. We're gonna tie everything together with a little bit of user interface, a little bit of HTML markup, CSS, and client-side JavaScript. Now again, if there are any other questions related to the previous session or to the previous sessions, now's the time to ask. And if there are no other questions, we can move to the steps of our fourth session. So again, what we'll do is we're going to create a single HTML file to the index page. And we're going to add a little bit of CSS to style it, to define the layout, right? As we were seeing in the GIF animation at the beginning, right? We will want to have some simple header and a sidebar with the tree view. And then we're going to add a little bit of client-side JavaScript that will define, again, the logic for the behavior of the tree view itself, and also some logic for actually loading models into Forge Viewer once we select them in the tree. So we're gonna encapsulate these two pieces of functionality in two JavaScript files. Forge tree JS is going to be the behavior of the tree view component. Forge Viewer JS is going to be the behavior of the viewer component that's going to occupy the rest of the real estate on the web page. All right. Now it's my turn to code again. So what we'll do is we can go back to our tutorial. And again, we're now at the final stage of our View Your Models tutorial. Again, we're going to switch to Node.js here, although again, isn't really a lot of difference because by this time you already have your server-side implementation ready, no matter whether it's built in Node.js or .NET Framework, .NET Core, Go, PHP, or Java. Now we're moving to the client side, which is really shared by, where it's going to be the same interface talking to the server, which can be implemented in different languages. Okay, so the public folder, if you remember that we've created earlier, is where we can start adding all our client-side assets to. Anything inside this folder will then be served to the client thanks to this middleware, right? So again, if we put index.html or some CSS file or some client-side JavaScript file, when the browser asks for that kind of, for any file that is actually found in this public subfolder, this middleware, this express.static, will make sure that it actually responds and sends that file back to the browser. All right. So let's start with the HTML file. This is, again, let me copy the content of the HTML and explain what it does. So here under the public folder, we're going to create our index.html. That's basically the file that's going to be served back to the browser if we go to just localhost 3000 without any additional URL. And what the HTML markup does is, in the head element, we simply pull in some dependencies for our user interface, right? So in this case, we bring in jQuery, Bootstrap, and JS3. jQuery, for those of you who don't know, is a library that used to be very popular for the client-side web developers that sort of unified the behavior in working with the DOM APIs with JavaScript across different browsers, because in the past, things were not exactly compatible, and different DOM operations in different browsers would require different methods. And jQuery was doing a really good job at unifying that. So you were able to use jQuery to, again, dynamically add a new HTML elements to your page, change them, change their properties, change their styles and things like that. Now it's not really being used that much anymore, but in conjunction with Bootstrap, which is another pretty popular dependency for web development, it's still relatively used. The Bootstrap is a CSS framework, responsive framework built by Twitter. So it's basically a collection of JavaScript helpers and CSS that helps you build responsive web applications. And by responsive, we mean applications that can actually be usable on different form factors. So whether you're viewing the web page on a desktop browser or on a tablet or on a smartphone, Bootstrap helps you build your user interface in a way that's responsive, so that layout can change for smaller form factors, for example, so that it's still not easy to read and easy to follow by your users. And finally, JS3 is a plugin for jQuery that we're going to use. Again, all those are third-party dependencies, and so is JS3. It's a plugin for jQuery that can be used to build tree views in your HTML dynamically. So all these, we're pulling them from Cloudflare CDN, and then apart from that, from their JavaScript components, we're also pulling in some CSS style sheets for, again, both Bootstrap and the JS3 plugin, right? So these are third-party dependencies that we're really using for some basic UI and for the tree view. And then we have two dependencies from Autodesk. It's a CSS style sheet file and a JavaScript file for our viewer. So I think now would be a good time for a side note. Again, if we go to the documentation section of the Forge portal, you'll see that most of the services we see here are web services or REST APIs, meaning that you use those by making HTTP requests to different endpoints, right? But there are actually a couple of components, namely this data visualization and the viewer. These two cards are not web services. These are actually client-side JavaScript components or libraries. These are used to, well, the viewer is really the most important one, the one that we're going to be using today. That's a JavaScript library built with WebGL, which is a widely supported HTML standard for 3D graphics on the web. It is a JavaScript library that you can use in any web application that you're building to preview any 3D models or 2D drawings extracted by Forge from your designs. So this is a JavaScript library, and if we look at the API reference, instead of seeing a list of server-side endpoints like we see with the other services, like with authentication or data management, instead here you'll see basically a couple of namespaces and JavaScript classes that you can use to interact with the viewer programmatically using the client-side JavaScript. All right, so that is the JavaScript library for Forge Viewer that we're pulling in here using the script element. And finally, while still in the head tag, we're pulling in 3 more dependencies: our own CSS style sheet that we're going to define somewhere under the public folder, and the Forge tree and Forge Viewer JavaScript files. So let's prepare our folders for these under the public folder. We're going to need one subfolder called CSS and one called JS. This is where we're going to keep our client-side assets. You don't need to strictly use these subfolders, but for clarity and structure, it's a good idea to organize your client-side assets into subfolders as well. All right, and again, since here we're using a relative URL, we're basically saying that the source for the script is just js/forgetree.js. The browser will know when reading this HTML markup, it'll know that it needs to find this forgetree.js file relative to the origin of this HTML itself in a subfolder relative, like that would be a sibling to this HTML file itself. So it'll be looking for a subfolder called JS, and inside there, it'll be looking for forgetree.js, right? So if we are at localhost 3000, browser opens this HTML, and it finds this relative path. It'll know that it needs to go to localhost 3000/css/main.css to get this spreadsheet. And similarly for the JavaScript files. All right, and then moving to the body element, this is where we actually define the body of our web page. Here we start using some of these CSS classes provided by Bootstrap. So there's a lot of these. And again, if you look at some basic Bootstrap tutorials, I think it's pretty straightforward, like easy to get started, at least with some of the basic classes. So things like navbar default. These are the classes that you will typically apply to an HTML element that you want Bootstrap to make is the navbar, the top bar, the top segment header of your web page. So inside there, we're basically just adding a link to forge.autodesk.com with some image that's pulled from our Autodesk.com domain. And after the navbar, we have the main container, which basically contains 2 things, right? It contains the sidebar where we're going to keep the tree view. That's going to be, I believe, inside here, inside a div that we named, that we gave the ID add buckets. And then it keeps another div, the rest, that's going to be used to host the viewer itself. Now, these call SM, call row, this is basically a grid system that's also part of Bootstrap, where you can easily segment your layout or your real estate into fractions of 12 units, right? So here, for example, if we're saying 8, that basically means 8/12ths, right? Or 2/3 basically of, let's say, a width of the entire width that's available. So it's this 12-unit based grid system that you can also find many tutorials on the Bootstrap documentation. And finally, we're also including one little form element. This one isn't visible. That's something we're going to use for uploading files to our server application. You can see that we're using an input element that is set to be hidden. And in here, you can see that this form is going to be used to make a post request to our server with this content type multi-part form data. And again, you may remember, that's what I was mentioning earlier, this is the content type that is often used when you need to make a request to some service, where that request should contain maybe multiple files or fields together combined, right? So multi-part form data is very frequently used for that type of thing. And we're going to use it here as well, again, to allow the user visitor of our web page to select a file from their file system and upload it to our server so that our server app can then send the object to Forge and translate it for viewing. And finally, the last div here is a modal dialog. And again, modal is another feature of the Bootstrap framework, which allows you to build like a modal dialog that will only pop up based on certain event. Right, so here, this is a modal dialog that we're only going to show when you click the Create New Bucket button. And in this modal dialog, we're going to ask the user to enter the name of the bucket, right? And warn them again about things like the uniqueness of the bucket name, and also about the fact that in this particular demo, the files are not automatically translated, but in this case, you will actually need to select a file in the tray view first, and then hit a translate button to translate it. Again, you can modify that in your own application if you want to. This is just to potentially to prevent you from wasting cloud credits in the Forge platform in your, let's say, trial subscription, because maybe you want to upload your files, but maybe you don't want to have them translated immediately and automatically. So that's our HTML markup. Now, if we go back to our tutorial, we can see that on the CSS side, we can there's really not a lot. You can just copy the rules and create a new file called main.css under our public/CSS folder. Format this. And basically, all we're saying here is that our HTML and main page should really occupy the full height of the page that we have available. Here is a fill class that we're using in our HTML as well. You can see this is the class we've defined in the CSS file, and it basically means, again, we want all these containers to occupy the full height of the real estate that's available to them. Otherwise, the divs will basically only expand in the vertical direction only to fit whatever is inside them, right? They wouldn't occupy the full height that's available to them. So we're changing that. And in this case, we're basically calculating the 100% of the viewport height minus 100 pixels that we use for the header, right? So we're basically making sure that the sidebar as well as the div that will host the viewer occupy the full height except for the 100 pixels at the top where we have our nav bar. And here's a couple more in padding and margin tweaks. And we're also specifying for the add buckets div where we're going to show the tray view. We're also specifying the overflow to make sure that if there's really a lot of items that we'll get a scroll bar, right? So that the whole thing, the tree view will not go crazy, overflow and extend the height of our page so that we need to scroll the entire page. We don't want that. We just want the sidebar to have a scroll bar if it has too much content so that we can scroll to the bottom of the last files. And and finally for the viewer itself, for the div that will host the viewer, we want to make sure that it occupies the full width of its available area as well. So nothing, I think, crazy or fancy there. Now, for the Forge tree, this is again going to be related to the tree view. This is going to define the behavior of the tree view that we are going to include in our user interface. So in the JS folder, on the public folder, create a file called forge.tree.js and add the content, the source code from the Learn Forge website. And again, what this does is quickly go through this. This $sign is basically a shortcut for the jQuery library that I was mentioning earlier. So it's a function that's just named $. Just use the $sign as its name. And the parameter to this is typically either a string identifying some HTML element or an actual instance of a DOM element, in this case, document or window. That document is the actual web page document element. And calling .ready on it basically means adding, specifying some code that should be executed once this DOM page or this DOM element is ready, loaded, or parsed. So what we do here, we basically say, as soon as the page is ready, we want to prepare the tree view, and then we want to define a couple of functions for event handlers, right? So we say, for example, if somebody clicks on an element in the HTML that has the ID refresh buckets, if somebody clicks on that element, we want to take another HTML element, this one with the ID add buckets. This .js tree is basically a jQuery way of retrieving a plugin for a specific element. So we're saying, okay, get the JS tree plugin for this add buckets div, and we're calling one of its methods called refresh. So in this case, we want to refresh the tree with all the data available provided by our server side, right? That was the different endpoints we were building that can list buckets or list objects inside a bucket. Then we also say if somebody clicks on an HTML element with the ID create new bucket, then we run a function called create new bucket. And later on, we'll see that that's where we actually use Bootstrap to show that modal dialog. And inside the modal, we basically say that when that modal dialog is shown, we want to add focus to a text input called new bucket key, so that the user can immediately start typing the name of a bucket without having to click inside the text field first. Finally, the last event that we're going to be handling here is there's going to be we have this hidden form file input, right, which is used to basically showing a file open dialog for you and allowing you to choose a file from your file system. And what we say here is that when that selected file in that file open dialog has changed, we want to react to it. And what we do here, we basically say if somebody opens the dialog and selects a file, what we're going to do is we're going to create a new request. Form data is, again, the content that's going to be sent with the multi-part form data request to upload our file to our server, right? So we're basically building this payload for this request using JavaScript. We create a new instance of this built-in form data class. We add in the name of the bucket where the file should be uploaded. We add the file itself, right? So this is basically accessed through this files property inside the function handler, this event handler. And then we use this $.ajax to make a request to our server, right? So if you remember, this was the URL for which we are handling this post request, right? So if somebody makes a post request to this URL, we expect that they're sending us a file and a name of a bucket where this file should be uploaded to in Forge. So that's basically what we're doing here. And once that request succeeds, we simply ask the JS tree plugin, the tree view sitting in one of our divs, to refresh that specific node belonging to that bucket. All right. Now, the helper method or function we used earlier, when somebody clicks on the create new bucket button, very similar here. We're making a request again, this time to API Forge OSS buckets. This time we're not sending multi-part form data. This time we're sending a JSON, and this is the payload, right? We're basically just sending a JSON object with a single property called bucket key. That's the name of the bucket we want the server to create for us. And if that operation succeeds, we just refresh the tree view and we hide the modal dialog from Bootstrap again. And if there is a problem, and if that problem is specifically the status code 409, we use this built-in alert function to notify the user, by the way, this name for a bucket is already used, so you need to come up with a different one. All right. And finally, the prepare add bucket tree, this is the function we're calling as soon as the page is initialized, is where we activate the JS tree jQuery plugin. So this is again how it works, right? We use this $ function to get a jQuery reference to an HTML element in our page with the ID add buckets. And by calling .js tree, passing in some options, we're basically initializing the plugin in there. In other words, we're creating a tree view inside that HTML element. So JS tree has its own set of options. You can find it online. You can specify some theme information, some icons that should be used depending on the type of node in the tree, right? So for example, for buckets or for objects, we're using slightly different glyph icons. But the really important part here is the data property, the data object here. So we're basically saying, we're asking the tree view to populate, to generate the tree view depending on any results it gets from this URL, API/fork/OSS/bucket. So again, if you remember, that's the OSS router that handles these API/fork/OSS/buckets, right? And it returns a JSON data in this special format returning a list of objects with properties like ID, text, type, and children. That's why we format the JSON here on our server side this way, because we want to be able to very easily, immediately use it in our tree view component here, right? Because this JS tree plugin requires the JSON data to include objects with properties like ID, text, or children. All right, and we also specify context menu. So this JS tree jQuery plugin allows you to also specify custom context menu when you right-click on one of the nodes of the tree. So here we basically specify that if you right-click on a bucket, we show one item that's basically just only used to upload a new file. And then when you right-click an object inside a bucket, we only expose one menu item. This one's called translate. And what this one will do is it'll trigger the translation of the file that you right-clicked on. So upload file and translate object are the last two functions in this JavaScript file. Upload file, what we'll do here is, again, remember that hidden form element that we have on our page. It's there, it's the file input, but it's hidden. And what we do is when you right-click on a bucket and you say, you choose the upload file item, menu action, we simply emulate click on that hidden element. So what will happen is when you right-click on a bucket and you say upload file, we will immediately pop up this select a file dialog. And when you select one of your files, we will initiate the upload of that file to our server application. And translating the object, again, if you remember, in our model derivative router, we have a single post request that we handle, and that's to this URL, API forge model derivative jobs, right? That's the request that we're going to make when you right-click on an object in the tree and you hit the translate action, a menu item. What we'll do is we basically clear out the contents of the viewer div, and then we basically make the post request to this API forge model derivative jobs endpoint in our server, right? Asking me to translate this specific object from this specific bucket. And when it's ready, we get the notification back from the server saying, okay, I've accepted your request, and now the file is being translated, and it may take a couple of seconds or maybe a minute. So in the meantime, we're basically just going to add an HTML content into the Forge Viewer div element in our web page saying, okay, the translation has started. Please try again in a moment. That's our Forge tree JavaScript file, again, defining the behavior of the tree view. And finally, Forge Viewer.js is where we'll define the logic for the Forge Viewer component. Now, if we copy the contents of the snippet, let's head over to our public/JS folder and create a file called Forge Viewer.js. All right. And what we do here is we prepare a helper function called launch viewer, which will basically start with this construct. On line 9, Autodesk.viewing.initializer is a global function provided by the Forge Viewer JavaScript library that we've included in our head element in the HTML. What it'll do is it'll make sure that all the dependencies that the viewer needs, that's things like, for example, different icons or environment images, textures, that all of these dependencies are available. And when they are, we can provide a callback function that should be called when the dependencies are ready. So what we'll do here is we say, okay, we want to make sure that the viewer environment is initialized, that the viewer has all the dependencies it needs. And when it does, what we do is we basically create a new instance of the most important class in the Forge Viewer APIs. That's the GUI viewer or viewer 3D. That's the main JavaScript class representing the Forge Viewer that you can use to access all or most of its APIs. So we basically say that we want this new instance of Forge Viewer to live inside this Forge Viewer HTML element. And we can even pass some additional options to the viewer. For example, what viewer extensions should be loaded when the viewer is created. And then we start the viewer for now without any models yet. But later on, you can notice that the launch viewer function accepts a URN as a parameter, and that is the encoded ID of one of the objects that you may want to show in the viewer. And what we do here is we call this Autodesk.viewing.document.load method with this URN, which also needs to be prefixed with URN colon. And what this does is this method will load a manifest that contains information about all the different outputs that Forge was able to extract from that particular design. So for example, in case of a Revit file, right, Forge can extract multiple 3D views and multiple 2D sheets from that one file. So there's one-to-many mapping, right? And all the outputs that Forge was able to extract are captured in this manifest, right? That's what we're loading here when we call this Autodesk.viewing.document.load. And then again, this is an asynchronous operation. So we need to provide some functions that should be called later, depending on whether the operation was successful or not. If the document loading was successful, what we say is we will simply get the default output from all the outputs that Forge was able to generate. We will ask the manifest to tell us which is the default one. And we simply call viewer.loadDocumentNode, which is the final piece where we're finally saying, hey, viewer, start loading this 3D view or this 2D sheet from some Revit file or from some IFC file or from Navisworks or Inventor file. Start loading it to your scene. Right, so this is where the actual loading of a model into the viewer happens. And if there's any problem with loading the manifest, the document, we simply output it to the console. And now, circling all the way back to the beginning, to the authentication, right? If you remember, when we were developing the authentication router, we implemented a handler for this get API Forge OAuth token request, right? That's the very first endpoint, server endpoint we were trying in the browser. Now, what is this used for? As we showed in the diagram earlier in the slides, right? Most of the communication really happens between our web page and our server, right? So whenever we want to get a list of buckets or a list of objects or upload a file, we always communicate with our server application, and then our server application, it generates its own internal access token that has all the required privileges, and the server app that communicates with Forge on our behalf. That's how most of this demo app works. However, the viewer itself, when we want to ask it to start loading some model from Forge, the viewer will actually start communicating with Forge directly, right? That was the extra arrow from our client-side JavaScript to Forge. So simply by calling this viewer.loadDocumentNode or by calling document.load, we're asking the viewer to start communicating with Forge on our behalf. But there is a problem, right? As we mentioned earlier, whenever you need to communicate with Forge, you need to authenticate yourself and you need to prove that you are who you claim to be. and that you're authorized to access certain resources and to make certain operations. That's why we built this API Forge OAuth token server-side endpoint, so that the viewer could actually ask our server for a token and then use this token to communicate with Forge, right? And here's where the magic happens. When we're calling the Autodesk.viewing.initializer, right, the first function that actually sets up the environment for the viewer, we pass in the first parameter to this function is an options object, where we can specify things like whether we want to connect to production servers of Forge or to staging servers, right? But more importantly, this allows us, this options object allows us to specify a function called getAccessToken. And this function will be used by the viewer whenever the viewer needs to get an access token to communicate with the Forge platform, right? So basically what we're saying is whenever we create a new instance of the viewer, there can be multiple viewers at on the same page. Whenever we ask it to load some data from Forge, right? The viewer will use this function to retrieve the token. And here's what the getForgeToken function does. It simply makes a request to our API Forge OAuth token, right? This is, again, the only authentication router method that we've implemented on our server side. We will return the access token, right? And this getForgeToken function that the viewer will use, all it needs to do is accept a callback function. And when the token is available, your getAccessToken function simply needs to call the callback with the token itself and the number of seconds during which the token is still valid. And this is, again, needed by the viewer so that if, let's say, you say that the token is only valid for the next 35 minutes, if the viewer needs another token in 35 minutes, it will know to call this getAccessToken function again. All right. And I believe that should be it. So let's try running our application again. See if everything is expected. So our server is listening on port 3000. All right. Now if we go to localhost, now you see that we've hit that express.static middleware. So the Express application actually responded with the content of the HTML, right? Because by default, if you don't provide any URLs, the browser will basically try and look for index.html or index.html. And in this case, this worked. So our browser received an HTML page that we've built. And as soon as it parsed the head element, it knew that it needs to start downloading some additional JavaScript files for jQuery, Bootstrap, and the Tree plugin. And it knew that it had to download a couple of additional dependencies from Autodesk, right? That's the Forge Viewer JavaScript and the Forge Viewer styling, because the Forge Viewer uses a little bit of CSS for its own user interface as well. And it also knew that, the browser also knew that it had to download our own CSS file and our JavaScript files. Okay. And yeah, it looks like I still left the EMEA region configured in my server-side app. So I'm now working with my European buckets here, basically, but that's fine. That'll work. So now what we can do is we can hit this new bucket button, which will bring up the Bootstrap modal. This is the modal dialog, right? For now, I'm not going to create any other bucket, but here's where you could do that. And when you right-click any buckets that you see in the tree view, you'll get the option called Upload File. When I click this one, this is where we, using jQuery, where we basically emulate a click on that hidden file input button. That will bring up, as you can see, that will bring up a, select a file dialog. So again, what I'm going to do is I'm going to select some sample file from my file system, maybe a DWG. And maybe before I do that, let me switch back to the Visual Studio Code and put a breakpoint somewhere on the server side in the OSS router, right? This is where we handle the file upload. Let me see here. This is our post request to API Forge RSS objects. This is the endpoint that our client-side JavaScript should call to upload the file to us. All right, so I'm going to select this, let's say, robot handling cell DWG drawing. Now you can see we hit the breakpoint on our server side, and thanks to the Multer middleware, the request object, which typically only contains some standard request information, should now also include property called file. And it's here. See, so what happened was this Multer middleware was able to parse the incoming request with the, what was it called, the multi-part form data content type. And it was able to see that there are a couple of fields, that there is a, in the body, there was a field called bucket key, where we defined the name of the bucket where we want the file to be uploaded to. And then there was another parameter called file to upload, which was actually containing content of a file. That was the DWG file I selected from within my browser. Right now, that file has been stored in a local uploads folder under this random string. So what we're going to do here is we're basically going to try and read this file into memory. Let me put a breakpoint inside there as well. And now inside, this is a callback function to the read file. So if there was any error, we would just send the execution to another web request handler, or maybe to the catch-all middleware at the very end that would just respond with the error message. But now there is no error, which is good. So now what we're going to do is we're going to, again, create a new instance of this objects API class from the Forge SDK, and we're going to upload this buffer that's now available here in memory, right? That's our entire DWG file read into memory. We're going to send it to this specified bucket name under a specific name, in this case, robot handling cell DWG. All right, we're going to try and do that. All right, now the upload was successful, so we can simply respond with 200 OK response back to the client. All right, so now if we go back, we can now expand our bucket, and you'll see that our DWG file is there. But, and again, maybe for completeness, let's try and go back to our VS Code extension. If I switch over to the EMEA region, you can see that I have my DWG file available here as well. But this file hasn't been processed, hasn't been translated with the Forge model derivative service yet. So now if I try and simply click on it to view it, right, the JavaScript code will try and open it in the viewer. And if it fails, it says, yep, the file is not yet translated, right? So I can either trigger translation from here by hitting this start translation button, or by right-clicking and hitting this translate menu item here. And again, by the way, in the extension, you can do the same thing. If you try and expand it, you'll see that, okay, there are no derivatives yet generated by the model derivative service. So you'll want to translate it. Here you can do it in a similar way by right-clicking that object and selecting the translate object. So let's do that from our own application. I'm going to say, right-click the object in the bucket and say translate. Now we're notified that the translation started, right? And that, again, depending on the complexity and size of your design, this may take a while. But here, if I now refresh this tree, hopefully soon we'll see that this translation is now happening and in progress. Not. Oh, it is. All right. So for some reason, it didn't show up, it didn't refresh here. Not sure why. Let's see, let's try it again. Oh, interesting. Maybe that could be because of the regions as well. So here we can already see that our file has been successfully translated. So now when we click on it again, we see the 2D drawing that Forge was able to extract from this DWG file. And that is our first simple Forge application. All right. So we're done with our final step in this tutorial for today. Again, now is your turn. We won't have any other sessions today. So what will happen is I'll stick around for, let's say, half an hour. You have time to wrap up your application now. And if you run into any problems, again, let me know in the chat or in the Q&A, and I'll try and help you out. All right. That's it for today. And again, tomorrow we're going to be looking at another tutorial from the Learn Forge website, helping you, basically guiding you through the other tutorial. It'll look similar to this one, but it'll basically, instead of you having to upload and translate your files, it'll actually allow you to browse your existing content in some of the third-party or some of the products, existing products built on top of the Forge platform, such as BIM 360 or Fusion Team or ACC. What we're going to be looking at on Tuesday. And then Wednesday, we're going to be focusing on the viewer side of things. We're going to show you how you can customize the viewer that we've just inserted into our simple web page today, or how you can start extracting information from your models using the viewer APIs to generate dashboards and sorts, for example. And finally, on Thursday, my colleagues will guide you through another very important service in the Forge portfolio, the design automation service that can be used to basically closely integrate your custom workflows with Inventor, Revit, 3ds Max, or AutoCAD applications. It's basically a way for you to run these products remotely on Forge servers and generating or modifying existing design files with these, again, with Revit or Inventor or AutoCAD 3ds Max using your custom plugins without you having to have those desktop products installed locally. Okay, now beyond this event, you want to get support, we recommend that you head over to Stack Overflow. We're trying to be active there and answer questions. Or if you have something more specific to your product, to your solution, something that maybe you cannot or don't want to share publicly, you're free to reach to us using the official email alias that is available on the Forge portal. So if you head over back to forge.autodesk.com and you go to support, get help, you can basically submit your questions through here as well, and we'll get notified of this. That we'll get a ticket in our system, and we'll get back to you as soon as we can. All right, that's it for today. Thank you for joining me. Thank you for staying with me throughout the day. And again, I'll stick around for roughly 30 minutes. So if you have any questions, feel free to ask in the Q&A or in the chat, and I'll try and help you out. Thank you so much. And for hopefully with most of you, I'll see you again tomorrow morning. Thank you.